d times d minus d times d times d is equals to 150. How do we solve for d? D times d, it is same thing as writing d to the power of 2 minus d times d, we can rewrite it as d to the power of 3 equal to 150. This means that d to the power of 2 minus d to the power of 3 is equals to 150 could be written as 125 plus 25. So d to the power of 2 minus d to the power of 3 is equal to 125. We can write it as 5 to the power of 3 plus 25. We can also rewrite it as 5 to the power of 2. Now, let's move each of these guys to the left hand side. So we have d to the power of 2 minus 5 to the power of 2 minus d to the power of 3 minus 5 to the power of 3 equal to 0. You will see that I can put these two guys in brackets. So that will be d to the power of 2 minus 5 to the power of 2. Also, I can put these two guys in brackets. But before that, I need to factor out the negative sign. So that will be minus into d to the power of 3 plus 5 to the power of 3 equal to 0. At this stage, we need to recall some algebraic properties. The first one is difference of 2 square. A square minus b square is equal to a plus b times a minus b. Also recall that the sum of two cubes, a cube plus b cube, is equal to a plus b times a square minus ab plus b square. Take note of these two beautiful properties. It is very important. Let's apply this first property to this guy. Doing that, we're gonna have d plus 5 times d minus 5 minus. Now, applying the second property to this guy, we simply have d plus 5 times d square minus 5d plus 5 square. Everything equal to 0. This means that d plus 5 into d minus 5 minus d plus 5 into d square minus 5d plus, what is 5 square? 5 times 5, 25. Everything equal to 0. You will observe that something is very common. D plus 5 is common. I can factor it out. So that will be d plus 5 into d minus 5 minus d square minus 5d plus 25. These are round brackets equal to 0. Let's proceed further. So we have d plus 5 times d minus 5. Now, let us open this bracket using this negative sign. Minus times d squared, that is minus d squared. Minus times minus 5d, that is plus 5d. Minus times 25, that is minus 25, equal to 0. This means that d plus 5 into minus d squared, d plus 5d, that is 6d, minus 5 minus 25, that is minus 30, equal to 0. So, d plus 5 is either equal to 0 or minus d squared plus 6d minus 30 is equal to 0. From this line, it is obvious d is equals to minus 5. This is the first solution, and it is real. Now, let us solve this quadratic equation to get the values of d. But before that, multiply through by minus 1. This becomes d squared minus 6d plus 30 equal to 0. We can now easily solve this quadratic equation using quadratic formula. Quadratic formula says d is equal to minus b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. From this equation, a is equals to 1, b is negative 6, c is 30. So let's continue. D equal to minus, what is b? B is negative 6, minus 6 plus or minus square root of b squared, that will be minus 6 all squared minus 4 into, what is a? A is 1 into, what is c? C is 30. Everything divided by 2 into a, the value of a is 1. This means that d equal to minus times minus 6, that is 6, plus or minus square root of minus 6 all squared, that is 36, minus 4 times 1 times 30, that is 120. Everything divided by 2 times 1, that is simply 2. So d equal to 6 plus or minus square root of 36 minus 120, that is negative 84. Everything divided by 2. D equal to 6 plus or minus. I can actually write this as square root of 84 times square root of negative 1, all divided by 2. D equal to 6 plus or minus square root of 84. But don't forget, from the complex number, we know that square root of minus 1 is equals to I. So we have I here, all divided by 2. This means that D is equal to 6 plus or minus square root of 84 could be written as square root of 4 times square root of 21 times I, all divided by 2. D is equal to 6 plus or minus, what is square root of 4? That is 2 times square root of 21 I, all divided by 2. D equal to, you will see that I can factor out 2 from this numerator. So I have 2 into 3 plus or minus square root of 21 I, all divided by 2. Clearly, D equal to 2 cancels 2. We are left with 3 plus or minus square root of 21 I. This implies that D is either equal to 3 plus square root of 21 I, or D equal to 3 minus square root of 21 I. You will see that we have two complex solutions here. D equals to 3 plus square root of 21 I and 3 minus square root of 21 I, and only one real solutions that we obtain here. D equals to minus 5. That means in total we have 3 solutions for this nice algebraic equation. That's it for this video. Thanks for watching.